Here's what you might expect to see on a titration curve if you titrate a weak acid with a strong base. Okay, so in black is what we've already seen before, strong acid versus strong base. If I start with a weak acid in blue, I have a pH a little bit higher to start with. Again, slight change in the beginning, very rapid change both before and after the equivalence point that then levels off. But here's my equivalence point, slightly above 7. So when I titrate a weak acid with a strong base, I get a solution that is slightly basic. The weaker the acid is, as shown by the decreasing Ka values, the higher the initial pH. So we can see we have a higher initial pH, the weaker the acid is. And the pH near the equivalence point is much more subtle. Okay, so we have these very slight changes at the equivalence point, the weaker the acid gets. Okay, what if I titrate a weak base with a strong acid? This is what you might expect to see in blue as a titration curve. So in black is a strong base and strong acid, where our equivalence point is a pH of 7, as we know. If I start with a weak base, I have a slightly less basic pH to start with. Again, that slight decrease, and then at the equivalence point, this big jump. And here's my equivalence point, where the pH is less than 7, so slightly acidic. If you perform a titration of a polyprotic acid, you will see an equivalence point for the dissociation of each hydrogen. So if I start with H3PO4 here, my first equivalence point is the loss of the first H+ hydrogen ion. Then the second equivalence point is the loss of that second hydrogen ion.